Good morning, everyone. Hope everyone doing well.
Yes.
Thank you for letting me know. So I uploaded your first review session recording that was done on Monday on Canvas, and I sent an announcement regarding that also. So if you want to go over what we did in Monday's class, you can go there. And you can see that recording only when you log in through your UNCG ID. And if you have any questions, just let me know. You can send me an email or you can come during my office hours and then we can work on it. Your test is on Friday. And as I mentioned, I'm going to open the testing window from 10 to 1. I will not, or I can say that I will suggest you not to join tutor's office hours during that time. If you have any questions, feel free to ask before and after. Once the testing window is open, you are not allowed to discuss these questions or concept check with the tutors at Math Hub Center. So if you have questions, you can ask before. And again, once the test is done and when we will meet next time, we will go over test questions. And I generally look at the, the statistic of the test and see if there is a question that more than 60% of the student miss. That means that either the question was tricky or the concept was not clear. So I'll give the points back. And again, when I'm saying giving points back, not necessary that it's 100% points back, but yeah, I will try to give as much as possible depending upon how the other student or how your whole class is doing. Excuse me. So that is about the test. Do you guys have any questions regarding the test? And again, I'm going to record this session also. And if it worked out well, like last time, I will upload that recording on Canvas as well. So I'll suggest you guys to hide your, or you can say that your camera should not be on for that. So if you guys have no question, then I guess I can start reviewing chapter 2. Let me see. So let's just quickly talk about what to. All right. So last time we talked about the format of the test, time of the test, and how many questions you expect, how many chapters. So if you go over this part, you will get it. The test is on Friday. And
she said that to me. She is good. She said to me, her subject got slapped.
all right. So the test is on Friday. The testing window will be from 10 to 1. And you will have about 20 to 25 questions in the test. And test format is exactly like how your quizzes are set up. You get one attempt. And again, the only difference with the quizzes are 70 minutes, but your test is 50 minutes. Again, as I mentioned earlier, your testing window will be from 10 to 1. So basically you have 3 hours and you can take that test during that window. Test will be on chapter 1 and 2. And again, if you accidentally open the test and then you close it, again, there is only one attempt. You have been doing the quiz, you have done quiz 1, quiz 2. So you know that if accidentally it's open, you will not get the second attempt to work on it. It is set up in such a way that you can open it once. So make sure when you are ready to take the test, then only open it. because if accidentally you open it, it will close after 50 minutes, whether you attempt it or not. And one more thing I want to let you guys know. When you yesterday, one student had an issue, like she was trying to open her assignment and she was not able to open, and every time it's showing some screen and it's saying on the screen it's saying error, and these there are blinking dots. So if you encounter this problem, and I think I mentioned before, but if not, you need to clear your caches and cookies from your browser. And if you need that information, how to clear that, this information is provided on your Canvas under Getting Started module. So you can take a look at that. And I will suggest you to do that before you attempt your exam, in case like if you get stuck in the middle or in the beginning. So make sure clear it and then you start working on that. And one more thing, let's say you took the exam, and when you submit it, you hit the submit button, and then you see this error, and it keeps on going. So that means there can be still an issue on your side. So the quick solution for that, like don't panic if you see that thing that you are trying to submit, but it's like 10 minutes and it's not submitting. You can call the customer support for Launchpad and just let them know. They can quickly check if it's submitted or not, or if not, they will be able to submit it from your end. So don't panic if you see that. And I'm not saying that you all will face this, but in case you face this issue, you should know that what should be my next step. And again, when I'm saying that if this is the issue, you need to call the customer support. So keep their number handy. It is provided in your syllabus. So just keep it on the side. And worst case, like if they do not respond or something, just send me an email and I can check on my side if it's submitted or not. But again, that is just a precautionary measure. If you see that, that means there is something. But again, there it can be fixed. So if you submit your exam and see if you have any issue, just wait for a couple of minutes, then it will work, and it will work out. And if not, make sure to call Macmillan customer support, and they will be able to do. They cannot do it when on their end they need your permission to submit. So once you call them, they will do it. So this is one issue I want to talk about. So last time we did test one review for chapter one. Anyone has any questions about any concept on chapter one? If you have any questions, I can quickly go over that first, and then I start chapter two. And if not, then I can move to chapter two. So anyone has any questions? No? All right. I think this is the max I can do. Okay, so last time we were talking about the density curve and how to find the area under the density curve, as well as when we have a density curve, what are the things that I need to know when I'm working with the density curve. When I work with the density curve, we talk about two types of density curve. One is normal and another one is uniform. So uniform density curve is not covered for your test one. We talk about uniform density curve. You had questions in your homework and quiz, but we are not covering uniform density curve because we did not do in much detail. So normal density curve will be covered in your test. So normal density curve, once you know that you are working with the density curve, that is single peak, symmetric, bell-shaped curve, we talk about normal density curve. Normal density curve has mean and standard deviation. And when we look at the area under the curve, or when we look at the corresponding z value or standardized or z score value, we make mean as 0 and standard deviation as 1. So we standardize it. Then we use standard normal table, table A, to find the area under the curve, or if the area is given, how to find the corresponding z, and using this z, how to find the corresponding x. You can also use your calculator. And as I mentioned earlier, if you're using table A, make sure that you have access of table A when you take the test. Table A is not provided in the test, so make sure you print it or you have access to that table during your testing time. So when we are looking at the area under the curve, you can use table. And if you're looking for corresponding z or z score, so x value, whatever the value of x you are looking for, just plug here and you get mean and standard deviation from here. Normal distribution, plug it and you find the corresponding z. Let's say z is this. Now, how to find this z value or how to find this value in the table? Go back to the table and find the corresponding z value. That gives you the area, and then is given to you in decimal. And if the question is asking you in the percentage, convert this into percentage by multiplying with 100. If the question is asking you to find the x value, we don't know the x and we also don't know the z. We know that the distribution is normal, but instead of x and z, I know the area. And area is given to me as 5% or 10%, 15% to the left. Then I can use this area. Either I can convert into decimals and use the table to find the corresponding z, and then plug that z here. Mu and sigma I know, I can calculate x. So z equals x minus mu over sigma, and my x will be z sigma plus mu. So these two things I have. This one I will calculate from here, and then I will find the corresponding x. You can use your calculator also, inverse normal, and then you can write area, mean, and standard deviation. Table gives us the left-sided area. So if you're looking for the right-sided area, subtract it from 1. If you're using the calculator, write the area to the left. If your right-sided area is given, make sure you subtract it from 100 and find the left-sided area and plug it here. So that's about chapter 1. So let's talk about chapter 2. So in chapter 2, we talk about bivariate dataset. When we are saying bivariate, we are working with two variables. One variable is your explanatory variable. One variable is your response variable. We use these two variables and then look at the relationship between two categorical and two numerical variables. So first thing, we need to identify what variable I am working with. And that we learn in chapter 1. Once I know what variable I am working with, then I can use different methods to find their relationship. If I am working with numerical variable, scatter plot is the first step that we do to look at the relationship between two numerical variables. So once you make a scatter plot, you need to know two variables, x and y, and then you can plot those x and y. You can plot those points using the value or the knowledge of x and y. So each dot represent x and y. You cannot make this dot until you know what your x is and what your y is. Once you make a scatter plot, that is the first step. And again, when you are making a scatter plot, if you know which one is your explanatory, which one is your response, plot or your explanatory on x and response on y. If you know. If you do not know, again, you can use any axis for explanatory or response, because we do not know which one is my explanatory, which we also call as independent variable and dependent variable. And why it's dependent? Because we don't get response until we know our explanatory. So this variable is dependent on explanatory. So once we know that we have two variables, we plot that on a scatter plot. Then our next step is to see if there is a relationship going on. And to look at that or to read a scatter plot, we do four things. First thing, we look at the form. If the form is, or let's say, look at the form is linear and non-linear. So when I'm saying non-linear means any shape, no matter what the shape is, except the linear or in the form of a line. Any other form other than linear is non-linear. It can be curve, it can be a circle, it can be anything. Once we know our form is linear, then we can look at direction. So what is the direction of that linear form? So is it going upward or is it going downward? So if it is going upward or downward, and when we're saying upward, so that means if x going up, y is also going up. If x going down, y is also going down. So they go in the same direction, then our linear relationship is upward. If your x is increasing, y is also increasing, or if x decreasing, y decreasing. Downward, one increases, other decreases. So it goes in the other way around. One is going down, other is going up. But again, they are both linear form. So it's not necessary that all the time if we increase x or y increases. It can increase or it can decrease. So that upward and downward linear form will help us to see what's going on. If x increasing, what happened to y? Is it increasing or decreasing? Once we know the direction of a linear pattern, the next step is we look at the strength. And again, when I'm saying strength, that means how close the points are in a scatter plot when I try to fit a line inside that scatter plot. So that will give me the strength of that linear relationship, or strength of that linear relationship. So when we are saying strength, again, it is very subjective when we just look at the scatter plot and say that it is very strong, very weak. But there is a numerical measure that gives us the strength of a linear pattern, and we call it as correlation coefficient, or rho or R. They both represent correlation coefficient. And when we talk about R, the value of correlation coefficient is between these two numbers. It should not go above 1 and -1. So it should be in this range. The max it can be -1 or +1. When R is -1 or +1, it talks about the perfect linear relationship. And when we say linear relationship, the name or another name for linear relationship is correlation. So when we are talking about correlation, instead of using two words linear relationship, we are saying they are correlated. They are correlated means there is a linear relation. Now, what kind of correlation? Then it will, negative and positive sign will tell me if it's upward or downward, positive or negative. So if it's negative sign, it's negative relation, negative linear relation. And if it's positive, it's positive linear relation. So when we go between -1 to 1, we pass across 0. So if there is the value of R equals 0, that means there is no correlation. So as it moves away from 0 in any direction, the correlation is getting stronger, or linear relationship getting stronger, and it moves closer to 0, it's getting weaker. And at 0, there is no correlation. So though 0 comes between this range, but 0 means if we have anything 0, how much money in my pocket? 0. So that means I have no money. So when we are talking about correlation, we need to be careful that anything above or 1 or -1 that does not mean that they are correlated. So correlation number, or R, is always a fraction or a decimal, either a fraction or a decimal, because it is between -1 and 1. So there are two whole numbers. So when it's at -1 or +1, it's perfect linear relation depending upon which direction. If negative sign, negative direction, positive, positive. But other than that, it will be either in decimal or fraction. So it cannot be any whole number except these two. Once you find the strength of the linear relationship, again, next step is I need to look if there are outliers in my data set. And when we are saying outliers, we talk about outliers in chapter 1 also. Outliers are something that lies outside the overall pattern. And we also talk about influential points. And there was a question in your homework assignment also. When we are saying influential points, what are influential points? So when we talk about outliers in your data set, if by removing that outlier in your scatter plot, change the value of your R, then we are talking about that point as an influential point. If it's changed it drastically, then that point is considered as influential point. And if it's not influencing, whether you keep or remove, then it is that outlier is not an influential point. So all outliers are not influential. So influential points are those when you remove or keep, they change your correlation or they change your strength drastically. Next, once you know there is a correlation going on, again, the next step is do the regression. Do the regression analysis and predict the values of y using the values of x. And when we are saying predict, so we say use this. And when we are saying least square regression line, actually, again, the definition, the proper definition is provided to you in your chapter slides as well as in your book. But again, least square regression line is the line that minimizes the sum of the squares of the distances between the points. And again, this is the definition. And as I mentioned earlier, make sure you know what this definition means. So technically, this definition is saying that if you try to fit a line in a scatter plot, then you fit a line in such a way that that line is as close as possible to all the points in your scatter plot. When we try to fit a line in this, your value of x bar and y bar, or in other words, mean of x and y, this line always passes through this point. So when we are talking about least square regression line, again, when you fit a least square regression line, x bar, y bar, or your line always passes to the mean of both your x and y. So this point is always on the line. Again, when we say least square regression line, and when I say least square regression line y on x, so that means I'm using y equals b0 plus b1x, and then I am looking at the predicted value of this. So I'm looking for y hat. Y hat means my predicted value of y when my x is changing. And again, we need to know the interpretation of the equation. And you had questions in your homework assignment and quiz where it says that this, what is this? This is your y-intercept, this is your slope, this is your explanatory variable. So if I'm predicting y, let's say I'm talking about weight and height. And if I'm predicting weight according to the height or height according to weight, one is my predictor variable, one is my explanatory variable. So how the value of explanatory variable multiply with the slope, and that will add or subtract depending upon what my slope is, will that increase or decrease my predicted value of y? So you need explanatory variable to predict the response variable. So every increase in, and I think there is a question in your homework or quiz where it says that goal and how many goals you do, and it increases something. I don't remember exactly, but every goal when you do, it multiplies with this your slope, and again slope is positive or negative. Accordingly, your value will add or subtract from your y-intercept. So interpretation, again, everybody should know how to interpret a least square regression line. Then residuals. So when we try to fit a line, then we will see how good that fit is. So we make residual plots. And again, residual plots is hard to make manually. So we use some kind of software to work or to make residual plots. And what is residual? So if you try to fit a line, and there are these points. So this is my actually the observed value that I see in my scatter plot. But when I fit a line, now this value is here. And this is my residual. And residual is the difference. This is my observed value. And this is, since it is on the line, now it is my predicted value. So it is the difference between y minus y hat. So this is for one point. And then similarly, I can look residual for all of these points. And then I use those residuals. So let's say if I have 20 points, I get 20 residuals. And then I will use those residuals. That, let's say this is one. And similarly, I will get one for this, this, this. So once I get the residuals, then I will plot that residual, and then I can see that if those residuals are scattered around the zero, if they are away from zero in any direction, and again, we use +2 -2 bound, +3 -3. It's not necessary that all of them are scattered around zero. There 95% of them are within +2 -2 bound. But again, if they are outside, they are considered as outliers. But if they are not scattered around zero, you see the points everywhere. That means this line is not a good fit. So residual plot help us to see if this is a good fit or not. We can also make QQ plots. And then we can check the linearity, or if the assumption of if you have all these points, and then see if you can make a line and they are on the line, or you can see some of them are around the line, some of them are far away the line. That will help us to see how good fit your line is. We can also use R square. This R square talks about the variations in your, explains the variations. And you can use that in percentages. And when you get the R output, when you get the R, not R output, you get the output from either SAS, SPSS, Minitab, or any software you use. It gives you an output. And in that output, you have the value of your intercept, you have the value of your slope, you have the value of R square. Sometimes the equation, sometimes that, or most of the time, especially when you use Minitab, it also provides you the equation. And it says that, like, what is your explanatory variable mortality rate? And I'm taking the example from your homework. And it says that some value of intercept minus the value of slope times dew points, something like that. So we know that this is my explanatory variable. What I'm predicting should be here. And this is my B0 and this is my B1. And if it is negative, I know that my slope is negative. So my correlation is negative. So again, sometimes this equation is provided to you. Sometimes you have to read the output and then you need to make the equation. Once you make your equation, if you know what is the value of dew point, and let's say this dew point is my X or independent variable, and I want to check, since intercept and slope is fixed no matter what your value of X is, because that's what your equation is. So I'm just taking some numbers, and again, I'm just taking it. So if I want to check what happened to my mortality rate when the dew point is increasing or decreasing, so let's say I take X as 1, X as 2, X as 3, or any number, is my value of Y increasing or decreasing? So this will give me the predicted value of Y when my X is 1, 2, 3. And we see that our slope is negative. So no matter what number I'm going to multiply with this, it will get subtracted from here. So it will goes down, it will keep on going down. So it will stay positive until some point. But as the value keep on increasing and this number multiplying with x gets bigger than this, then your predicted value of y will be negative. So it will stay positive until 1.5 is bigger than the multiplication of these two. Once it gets smaller, then the value of y will get lower. So you can say that if you're moving from positive to negative, that means your values are going down, and you can see that your slope is negative. So that is one part. R square, again, help us to see how many variation, and we also call it as coefficient of determination. The value of r square is most of the time given to us, and if the value of r square is not given, we can, if we can find the value of r, which is your correlation coefficient. This one we use for correlation, and this one we use for regression. They both have a connection, though they are used for different purposes. Correlation, we do not, even if we do not know the distinction between explanatory and response variable, we can find the linear relationship. But when we are talking about regression, the important step that we need to know is we need to know the difference between explanatory and response. We need to know which one is my independent variable that I'm using to predict the value of my dependent variable. So once you know that, again, it will help you for the prediction. But if you want to see how good fit a line is, then and you know the value of r, do the square of that to get the fraction of variation or coefficient of determination or r square value. And if you know the r square, do the square root and get this. When you do the square root, you get both positive and negative. Again, look for the other clues. If you have scatter plot, then scatter plot will tell you if you are working with the positive or negative form. And if you have slope, then look at the slope. If its slope is positive or negative, and then you can work with that. Any questions so far? So this is your equation that we use, and as I mentioned, you need to know how to interpret this equation. The next step is if B0 and B1 is not given to us. Straightforward, how do we do that? If we have this information. And again, if there is a question on finding B0, B1 in the exam, I am not going to provide you a big data set where you have to calculate. If there is a question, then these values are given. So use these value because your time for the exam is only 50 minutes, and it will take long time to calculate the mean for each and standard deviation for this and correlation. So if there is a question like this in the test, these values are provided, just that you need to identify which one is your explanatory, which one is your response, and you can see that what you are predicting. So if X bar is not given, if it's given that mean of the mortality rate is this, and standard deviation of the mortality rate is something like this, and dew point is this, and mean standard deviation of dew point is this. Now predict the mortality rate. So this is not giving you what is X, what is Y. But when you say that you are predicting the mortality rate, the moment you read that word or the moment you find other clues, you know that if I'm predicting that, that is my Y. Or predict the dew point thing using the mortality rate, then this is my Y. And once this is Y, the other is your X. And then you can see this X1 is, if this is mortality rate is my explanatory variable, and this is the mean for this. And this part is important again because when you calculate the value of R, or sorry, not R, when you calculate the value of B1, this is R SY over SX, right? So you divide with the standard deviation of your explanatory variable, and this is the standard deviation of your response variable. And B0, you can calculate using this. So you need to know your slope, and once you solve this, plug this value here, and these two values you can calculate depending upon what information is given, and Most probably, if there is a question, these values are provided to you. So this is about least square regression line. And again, when we do least square regression line, we need to be careful about few things. So when you are trying to predict the value of y using the value of x, there are few things, because sometimes there are few things that gives, if we do not take into consideration, or if we do not know ahead of time, they may give you false result. There might not be a correlation, but they are showing you a correlation. So if they are showing you a correlation and you try to predict the value of y using the value of x, your predictions might not be correct. So you need to be careful about few things, and one of them is extrapolation. And we have done the example of height and age. So as your age increases, your height stops growing at certain age. So if you keep on predicting far outside the range, let's say 30 years, 40 years, 50 years, it will still give you the correlation. You can see that if you see for first 20 years, it just keep on increasing. And if you see for 50, 40, 50, 60 years, according to this pattern, it will just keep on increasing. So you see a correlation, but that correlation again will give you misleading results when you try to predict. So I can see there is a correlation in age and height, but are up to a certain age. We all know that it stops after that particular age. But if I just look at this pattern and keep on going and try to predict at the age of 50, 60, 70, I still see there is a positive linear relationship. But this is misleading. When I tried to predict what's the height at the age of 60 or 50, it's 8 feet 9 inches or 9 feet, and that is not possible. Why? Because we are suffering from extrapolation, and extrapolation is something when you try to predict something far outside the overall pattern. The next important thing is lurking variable. And again, lurking variables are also called as hidden variables. So those variables are not in the picture. You don't see that in X or Y, but they are still influencing your results. And again, if they are influencing your results, that will also give you false prediction if they are influencing. And we have done an example of lurking variable in our categorical variable also. When we use Simpson's paradox, we say that if we keep lurking variable into consideration, we have different results. But if we ignore lurking variables, they give us totally different results. So again, lurking variables are important. And in chapter 3, we are going to talk about how to control the lurking variables, or what are the remedies we need to do to avoid the effect of lurking variable in our experiment. So that's our chapter 3. But right now, you need to know what lurking variable is and how they can influence your results and give you a wrong interpretation. And the next one is confounding variables. And those variables are called mixed variables. And when I say mixed variables, that means you cannot see, or you can see a response, but you cannot distinguish, is that response from my explanatory variable X, or there is another variable X? There is another variable X1, X2, X3, because I have so many variables. So the effect that I see on Y is just because of this or this or this. So when I see a mixed response, then I'm talking about confounding variables. So again, confounding variables also interpret your results, or also influence your results. So make sure that you take care of the effect of lurking and confounding variables, and that's what we are going to learn in next chapter. So, and one more thing, no matter how strong the correlation is or how strong the linear relation is, it does not imply causation. Correlation does not imply causation, or you can say that no matter how strong your linear relationship is, we cannot say that there is a cause and effect relationship going on between these variables. So again, correlation is different than causation. There is a correlation, but not necessarily there is a causation. Maybe, maybe not. But we cannot say that correlation implies causation or causation implies correlation. Correlation does not imply causation. And another important thing that I want to tell you, association and correlation. What is the relationship between these two? So when we are saying association, two variables are associated. But can I say that they are correlated? And the answer is no. Two variables are associated. There can be any association. Association means relation, right? So there can be any relation, not necessary that it is linear. But if this is linear association, then I can say yes, there is a correlation. If there is a correlation, will there be an association? And the answer is yes. If there is a correlation, there is a relation. And what kind of relation? We know that it is a linear relation. So the last topic, two-way tables. So far we talk about how to look at the relationship between two numerical variables. Now, if we are working with two categorical variables, we can use scatter plot, but scatter plot does not give us any relationship. We can use to represent, but it does not help us to see any relationship. If I'm looking at two-way table, first of all, how to make a two-way table. So I can make a two-way table and I can find I can make a marginal distribution. And when you say two-way table, a table that has two ways to walk through. One is through your rows and another is through your column. So once you have a two-way table, you work with the margins, or you can say you work only with the margins. Then you are working with marginal distribution. So the extra row and extra column that we created. So we look at the sum of the row or the sum of the column and divided with the grand total or the sum total or the number of observation. We are talking about marginal distribution. Marginal word comes from margins. So when we work with the margins of the table, we are talking about marginal distribution. Again, if we are working with the margins, marginal distribution does not give us any information about the relationship of two variables. If I'm looking at the relationship between two variables, I work with conditional distribution. And again, when we are working with conditional distribution, we need marginal for sure, because when we are working at the conditional distribution, our margins will help us to find the denominator. And let me talk one more thing about joint distribution. So let me talk both together, conditional distribution and joint distribution. So when we need to get the relationship between two categorical variables, we work with conditional distribution. And again, when we are saying conditional distribution, we are looking for some condition. So when we talk about conditional distribution, the first step is we go inside a cell and our numerator comes from the cell. And again, when we are going in the cell, we need to know the row and column, because this cell is a combination of the column and the row. And once we know the cell, and then we are looking at what is my condition. Am I looking at this with this or this or this? So when I'm dividing with the row, sum of column or sum of row, then I'm looking for the sum of all the entries in that row or sum of all the entries in that column, and this comes from here, and which is again what we discuss in marginal distribution. And what is this joint distribution? When we are talking about joint distribution, then how do we define joint distribution? So if the count in each cell of a two-way table are divided by the total number of observations, the result is the joint distribution. So if you need to make a joint distribution table, how do you make that? So you look at this cell. Let me make it cleaner. So we go to this cell, and then I'll see how much is this. What is the value of this in percentage among all? So I divide with this and I will write it. I'm just writing some number, let's say this. What is the joint distribution of this? So I will look at this and then divide it with the grand total. And same thing, what is the joint distribution of this particular cell? So then divide with the total and write here in something like this. So whatever the percentages are. And that gives you the joint distribution. When we are talking about conditional distribution, again, we are looking for which cell I'm going and what number I am dividing with. So what should be my denominator? Is that denominator coming from my sum total or grand total, or it is coming from my what do you say, row total, sum total. So your denominator will be different here. So marginal distribution, you look for the numerator and denominator both from the margin. But in conditional distribution, numerator always come inside the cell. So numerator is coming from the cell and denominator is coming from the margin. So read the question, and again, in your homework and quiz, there are a lot of questions on conditional and marginal distribution. But since the test is covering both chapter 1 and chapter 2, for each topic, I'm just giving you one or two questions depending upon what topics our SLOs are covering or what topics are more important for us in this chapter. Again, there will be only 20 to 25 questions, and I cannot cover every single topic. And if there are questions on each topic, there will be one or maximum two questions, not more than that. So, my whole point of telling you this is read the question carefully. Is the question asking me only to look at the margins? Then you just work with the marginal distribution. But if it's specifying you to go inside a cell, if you're going inside a cell, you're looking at the numerator from the cell, then definitely you are not working with marginal distribution. You are working with conditional distribution. And there will not be any question where you have to make a table for the joint distribution, but I want you to understand what joint distribution is and where is this table comes from. So if we say the joint distribution table, so this table comes when you look for each cell and look at the how much is that cell or what's the percentage of that particular category from all, and then you find that. And the last topic is Simpson's paradox. And as we discussed a few minutes back, when we talk about Simpson's paradox, there is a variable that if we keep that into consideration or if we do not keep into consideration, it can reverse our results. It can totally reverse our results. And that variable is lurking variable. So when we are talking about Simpson's paradox, we say that when we work with two individual two-way tables, then we have what results we get. But when we combine those and ignore the lurking variable, our results are totally opposite. And that is just because of the effect of lurking variable keeping into consideration or not keeping into consideration, and that can change our results drastically. And then we can say, and we did an example about how to when we had two schools acceptance rate for male and female, and then when we combine the acceptance rate and ignore which school those particular applicants applied, and then look at the combined results, we see that more males got accepted. But when we look at their individual business and art school, and we found out that more females got accepted. So they were asking, is there a discrimination going on against male or female? But when we look at both results, they both are totally opposite. So we cannot say that there is a discrimination going on. But if, let's say, we look at individual two-way tables and we see that more females got accepted in both individual, and when we look at the combined results, there also we will see more females got accepted. And then again, we have to go back and check other things. We cannot still say that, okay, there is a discrimination going on now. So we have other factors to take into consideration. But yeah, now we are not talking about the lurking variable because we kept the lurking variable and we ignore, but our results are still the same. So we need to look for other stuff. So I guess that's all for chapter 2. But if you have any questions, feel free to let me know. So good luck, everyone, for your test, and have a wonderful. It's nice sunny day today. Tomorrow it's going to be a snow day, so I don't know how it's going to work, but yeah. So good luck, everyone. And if you have any questions, feel free to join my office hours in 10 minutes. Thank you,
Thank
everyone.
you.
You're
Thank
welcome.
you.
Thank you.
You're welcome.